Now, our patterns, our argument patterns, are general patterns. Anytime you have an arrow statement and another premise that affirms the antecedent, you can affirm the consequent. All right, so that works straightforward here. A arrow B, if N is here, Bob is here, N is here, therefore Bob is here. But it also works in a statement like this. If Ann is not here, then Bob is not here. What do you need in premise 2? A is not going to work because your antecedent is not A and your consequent is not B. So here's your P and it's not B that's your Q. Not B is your Q. So you need not A, therefore not B. This is modus ponens. Doesn't look like modus ponens, right? The pattern doesn't have a negation anywhere in sight, and this has negations all over the place. But the general pattern is arrow statement, antecedent, arrow, consequent, antecedent, therefore consequent. So you have to keep the pattern regular, okay? It'll also apply, the argument form also applies for other compound, even though if you P and Q are other compound propositions, right? If either the Mets or Dodgers make the playoffs, then the Phillies don't. Okay? 2. One of them did make the playoffs, therefore we affirm this consequent, which is not P. Okay? Here's our P, here's our Q, right? P repeated here, identical. Q repeated here, identical. Okay? P and Q can stand for any proposition. You just stay consistent. Whatever this proposition was, you just carry it. It has to be identical here. If it's a negation, this will be a negation. Okay? And same over here. That's the modus ponens pattern. Okay? Because the modus ponens pattern can work on something like, can give you a negative conclusion, you have to be very careful with seeing when you have it versus the modus tollens pattern. The modus tollens pattern is, again, you start with an arrow statement, but the second premise denies the consequent. Whatever the consequent is, you deny it. And then the conclusion is you can also deny the antecedent. The converse of these doesn't work, okay, are invalid. P arrow Q, Q therefore P is invalid. Sometimes I'll use 3 dots to with the slash to indicate conclusion. This is invalid. Just because the consequent is true doesn't mean the antecedent is true. This is invalid. Right? So you have to be very careful here. You can't deny the antecedent and therefore deny the consequent. If Ann is here, then Bob is here. Ann's not, therefore Bob is not. Bad argument. Okay? So you have to keep the negation straight and the order straight. P arrow Q, not Q, therefore not P. If Ann is here, then Bob is here. Ann's not here, therefore Bob's not here. Okay, so it works for that straightforward pattern. Ann implies Bob, not Bob, therefore not Ann. But it also works in cases like this. If Ann is not here, then Bob is not here. Okay, blow your mind here. Now, second line, you have to deny the consequent, right? How do you do that? You add a negation to the consequent. I know that looks funny, but it's not B. Not B is false. Now, that's equivalent to B, but hard degree wants you to keep the formal. You tack a negation onto the consequent, right? So this is indeed equivalent to B. If we had gone further with this, we teach you how to infer that, oh, not B is logically equivalent to B. There's a rule for that. It's called double negation, right? But don't worry about that. Just add a negation. You're looking for something where the consequent has a negation added to it in another premise. You have that, okay? And so you can conclude that the antecedent is false, right? So here's your P, here's your Q, here's your not Q, not Q, here's your not P, Okay, that follows the modus tollens pattern. And we're going to do it by adding these negations. We're not going to turn not A into A. We don't just turn the negative positive, double negative positive. Okay, because that's what you're going to see. And that's what you're going to have to relate if you have to do further inferences. So I want you to know this. Modus tollens works, again, if you have compound, right, two-place relation, right? How about A and B implies C, right? Your second premise would be not consequent, not C, therefore not antecedent. A and B are not both true. Here's your P, here's your Q, here's your not Q, and here's your not P. Okay, markers are having a little rough time today, but that's clear enough. Okay, and last with MTP, right? MTP. Let's see. P or not Q, right? Not P, therefore what? You affirm this half, therefore not Q. Either P is true or not Q is true. Since P is not true, this half is true, which happens to be a negation, right? Because negations aren't like bad guys. They're just propositions, right? You just expressed the negation of a different proposition, right? And as you can see with the double negation, right? Every proposition has a negation. Not Q, not Q, which is equivalent to Q, right? Q, not Q, two sides of the same coin. So the pattern in MTP is you deny one half and then you affirm the other. But if the other half is itself a negation, right, you have to carry it over perfectly. P, your little letter Q is actually not Q. You substitute not Q here. I probably should use A's and B's. So you have to carry it down perfectly, not Q. Okay, works for compound. Right, let's use A's and B's. A and B or not C. Premise 2 would be could be not A and B. Notice how it looks, right? It's this whole thing negated. Okay? Therefore, this is true, not C. Therefore, not C. All right, we're going to see this more when we practice. I went over it on Wednesday, so I don't want to, again, belabor it and make these videos over long. So we'll work on this in practice.